Hi, I'm Matthew Young, and I spent the last few years studying the distribution of water in natural and modified plant systems. My poster summarizes a few projects that I've worked on over the last few years involving NMR of plant materials. First, we image the structures responsible for water transport within a cornstalk by taking a series of 20-micron resolution transverse slices, which we then stitch together into a 3D model. Next, we observed how differences to the Larmor frequency and rotational correlation times impact T1 and T2 relaxation through measurements of water absorption in corn stover at both 2 and 250 megahertz. We found an unexpected trend when traversing the T1 minimum in the low field data. The data shows an expected T1 minimum as well as a minimum in T2, which indicates complexities in interpreting this data. Ultimately, this is a warning that data interpretation when crossing the T1 minimum can be messy and must be approached cautiously. In the next study, we observed differences in drying behavior of modified corn stover with T1, T2 relaxation measurements. We compared two types of pretreatments to see if we could detect expected increases in surface accessibility and mobility. We found a decrease in T1 over T2 in the driest states after pretreatment. A T1 over T2 decrease has been shown to relate to improved surface mobility. In the next study, we observed real-time differences in the hydrolysis of these same pretreated materials with 2 MHz T2 relaxation experiments. In the severely pretreated materials, we observed qualitative features indicating the extent of pretreatment, and with a calibration on sucrose solutions, we're able to approximate the viscosity of these materials during processing. The final study was monitoring the long-term swellability of corn stalk pith, hemp, and cellulose fibers through periodic T2 relaxation and diffusion measurements. Overall, we saw unexpected and dramatic trends in corn stalk pith. We saw more gradual change in hemp and no change in cellulose fibers, to which we attribute these behaviors to the known high, moderate, and low swellability of these materials. Finally, by combining these data, we were able to estimate the surface relaxivity throughout swelling, which could be useful for relating measurements on these systems to pore size distributions. That's the quick summary of my poster. If you have any specific questions or would like to learn more about any of these studies, please find me during the MRPM poster session or reach out to me. Thanks for your interest in my poster.